Good morning, chemistry students. It's Saturday morning, and I don't expect you to be looking at this on Saturday, but I'm going to post it, and you can look at it on Monday. Uh, if you remember, I gave you some reading to do in an online textbook uh, about atomic structure. And atomic structure, as you know, when we start talking about the atom, I'm going to go down here for a minute, see if I can do this. Atomic structure, we know that the nucleus of the atom, I don't like that pen. We have the nucleus, and within the nucleus we have protons, and for most every atom we also have some neutrons. Protons are positively charged, neutrons have no charge, and in a very simplistic model of an atom, we have electrons outside of the nucleus. Now, you've seen this type of a planetary model many times in younger years and in lower grades, ninth grade physical science. But this is not exactly the model of the atom that's correct, but it's one that's somewhat useful to us for predicting certain properties like transitions of electrons in a very simple atom like hydrogen. We're going to be going into great depth about that once the school year starts. But just for the sake of today, just understand that protons have positive charges, neutrons have no charge, and these are the nuclear particles, and electrons are the particles that are outside of the nucleus. In our very simple model, orbiting the nucleus, which is not a reflection of reality. Get my coffee here. But it gives us a basis upon which to start. Okay, so what do we need to know? When we start looking at the atom, we need to know that the atom's identity is uh, dictated by the atomic number. The atomic number, and the atomic number is the number of protons. So if we look at something and it has one proton in the nucleus, it's hydrogen. If it has two protons, it's helium, etc. So that number of protons is the indicator of the atom's identity. Now, we could have atoms with a certain number of protons that would give the atom's identity, but it can differ in the number of neutrons. And for example, I can have hydrogen. Hydrogen is just one proton in the nucleus and one electron. Okay, so I have a proton, and I'll call it P for the proton, and outside of it we can say, well, I've got my electron. So there's the simplest picture of an atom, the hydrogen atom in this case, but we can have a hydrogen atom that also has a neutron in it. This is called an isotope. If that neutron, represented by the open circle, is in the nucleus of hydrogen, it's no longer regular hydrogen, it's called deuterium. And we can also have another isotope with two neutrons. That's called tritium. So we have various, the word is isotopes, and isotopes are atoms of the same element with different numbers of neutrons. So when you start looking and reading about that, you'll be familiar with that word. Okay, just to keep you on the right track, let's go ahead and look at a periodic table. And I'm sure you're familiar with the periodic table. And again, I'm just kind of musing this morning, which is what I do on Saturday mornings. So I'm going to post this link to this article, and I do encourage you to read it. All these things that I give you are going to make you a better chemistry student, and I hope you don't look at them like, oh no, Koch has another thing for me to read. Well, how do you think I learn things? How do you think Mr. Phillips, Mr. Gargis, Mr. Eastman learn things? We read about them, we studied them, and with very little effort, 5 minutes here and there, you can really be a good chemistry or math or physics student. But be that as it may, I know some of you will read this and some of you won't. But regardless of that, please familiarize yourself with the periodic table. Now this article is really good because it takes you through, if you take a look here, all of the different areas on the periodic table that are of interest to us as chemists. Group 1, the alkaline metals. Group 2, the alkaline earth metals. Transition metals, etc. And one of the things I'm going to ask you to do is to be familiar with these names. So if I say sodium, I want you to think alkaline metal. If I say iron, I want you to think transition metal. Now, what do these things mean? Well, we're going to get to that, and you'll read about that. It deals pretty much with the metallic character of things and the non-metallic character of things. It differs in terms of number of valence electrons. As we look at the periodic table, there are certain trends that are evident that we're going to learn about and you'll read about, such as the atomic size, things like electronegativity, ionization energy, other things like that, whose definitions you will learn as we go along. So if you go ahead and read through these, like I said, this webpage will probably take you about, I don't know, 5 minutes to read through, but I do encourage you to read it, and I'm going to post it. So that'll be your thing to do for the week, and I'll post some exercises in terms of in the form of a Google form or something like that, and you can test your knowledge about the periodic table. So that's your task for the upcoming few days. Again, I don't expect you to do things this weekend, except if you think about it tomorrow, wish your father a happy Father's Day, or a father you might know, wish him happy Father's Day. So with that, I'm going to go ahead and post this. Again, some Saturday morning musings over coffee.